Hello everyone, my name is Dzulkifly. I will present you my work on thermodynamics experiment. So here's the experiment description. The topic is about measuring the effect of air, fuel, and compression ratio on fuel consumption. However, due to the time and condition, the experiment that is done is only about the air-fuel ratio effect towards the fuel consumption by adjusting the carburetor. The objective of this experiment is to determine the effects of engine component adjustment towards the fuel consumption. The object that would be measured for this engine configuration is a motorcycle. For the scenario, initially there are 5 scenarios would be experimented, but as mentioned the scenario that would be presented is about the air-fuel ratio adjustment. Then, for the variable data that would be get from this experiment are the distance and the fuel consumption. Before we jump into the experiment, let me present the essential information regarding to the experiment. The first one is about the object specification. Yes, it is a Supra, but not this Toyota Supra, but this Supra. Yes, the legendary Supra X 2005. Very durable at the time, smallest engine capacity but still powerful compared to its competitors. People call this Supra as Dad's motorcycle usually. Well, anyway, this Supra has 100cc engine capacity, 4-speed rotary, 7.3 PS power at 8000 rpm, and 0.74 Nm torque at 6000 rpm. Other specs can be read on the table on the left side here. The current condition of the motor can be seen on the picture on the right side here. Well, it is not at its best condition, but it still can cover high load. My dad usually use this to bring like a set of wheels and 2 car tires, and it still can run, it works. So yeah, legendary Honda motorcycle, just an intermezzo. Alright, then we go to for the mapping. Mapping is for projecting the path or road that will be passed for the experiment. For additional information, this experiment is held by 2 other companions, and the mapping is chosen by brainstorming between these 3 people. So here's the map road that would be used. The initial plan chosen because it is expected to have more straight road, which is good for maintaining constant speed. However, due to the fact that there are more crowds and elevation, final plan is built for the next experiment. Well, it is closer but less crowd and more flat. For the next is the tools preparation and pre-experiment. So here's the tools that is used in this experiment. There is a hose and bottle to make a fuel suction, screwdriver for carburetor adjustment, and 220 milliliters bottles for fuel receptacle. The amount of fuel is so small for each run so that there is less time expensed. And for the pre-experimentation, there would be assembly fuel suction, empty fuel tank, configuration adjustment, fuel filling, and start positioning. Point 2 and 2 forward would be repeated again before each run. Alright, let's go to the first configuration, which is default setting with air fuel ratio of 1 to 14.7. The video that will be shown is just a sample of 3 default experiment run that is conducted. So have fun, here's the video. Then let's see to the second configuration, which is reach setting by rotating screw 90 degree to the clockwise. And as the previous configuration, the video that will be shown is just a sample of 3 reach experiment run that is conducted. Then we are going to see the third configuration, which is lean setting by rotating screw 90 degree counterclockwise. As the previous configuration, the video that will be shown is just a sample of 3 lean experiment run that is conducted. After the experiment is done, the data recorded, and here is how looks like. The rich setting shows a promising efficiency for fuel consumption with longest distance span and low fuel consumption. The lean configuration shows that it is the least efficient setting seen from the recorded data from the experiment. Default setting shows a small difference between each run. For additional information, these runs are conducted in different times and conditions that may also give an impact into the data. For example, the data for the first run of default setting is using the initial map route. Therefore, it may affect the higher fuel consumption. Second and third run was run in the same map, which is the final map, but in a different condition. Third default run was in midday or noon, and second run was on the windy late afternoon. For the first, second, and third run of the rich setting, the map route is the same but different condition. The rich configuration was taken on the late afternoon into the night with drizzly condition. The third run was taken in the noon. For the lean configuration, all runs are using the same map, but the condition of second run is different. The first and third run was conducted in the afternoon in a cloudy condition. Second run was conducted also in the afternoon but during rainy condition. Other than that, the data arrangement is also different between each other. For example, the third run of lean, this one, was taken after the third run of rich, this one. However, for the first and second was conducted in the same day, focused on a single configuration. This arrangement may consider also effect on data on the experiment. Alright, let us go to the analysis. For the first point, the fuel consumption behavior. Observing from the experiment data, it is found out that the rich configuration is more efficient and covers longest distance compared to the other setting. Lean configuration found out to be the least efficient with the closest distance covered. And then the second point about the performance behavior, the rich configuration runs smoother and fast reaction. Maybe this is why a lot of comfortable cars such as S-Class or Rolls-Royce producing high-capacity engines such as V8 engine car, which is knowledgeable as performance engine, but for comfort purpose. For the lean configuration, the motorcycle runs more rough, yet it is also late response. And then for the third point, it is about the relation on performance to fuel consumption. The experiment is not expected to answer this kind of question since the runs is in idle or constant speed. However, rich configuration shows a combination of great performance but efficient fuel consumption. But this happened because we did not use it or measure it in a fluctuate velocity where the performance can also be measured. Therefore, further works and research can be conducted for this question. An additional expectation on the relation between performance and the fuel consumption should be proportionally equal, since the higher performance to the engine may require more fuel consumption. And then for the fourth point, for the relation on the temperature to the fuel consumption, lean configuration affects into more heat to the engine, and the rich configuration doesn't give a serious impact compared to the default setting. However, these parameters are not measured directly. It is only based on the human sense of what they are feeling. What I am feeling. But the references shows similar behavior of engine for lean and rich configuration, which lean may result into hot run or more heat, and rich configuration is considered and knowledgeable as cool run. So we've been talking about this rich and lean configuration, but do you know what terms is that? So rich configuration is a condition when the air ratio is less than the required to complete combustion inside the engine. And for the lean configuration is a condition when the air ratio is more than the required to complete the combustion in the engine. Based on my research on the motorcycle book from the vocational school, the air-fuel ratio is behaving differently in certain conditions. Generally, a complete combustion would expected to have an air-fuel ratio of 1 to 14.7. It is the stoichiometric value based on the chemical things appear inside the combustion. This lambda on the table is the ratio from the actual air in to the theoretical air in or entering the engine. When it is equal to 1, the combustion would be in complete condition. Below 1 means the run is rich and above 1 is lean. On low temperature, the forecasted air-fuel ratio is 1 to 1 to 1 to 5. The condition could make the engine cannot ignite and need additional fuel to be running. When accelerating, the engine becomes more airy, therefore it needs more fuel so that it becoming rich. At low speed and idle, the engine becoming lean. Thus, adjusting carburetor to rich condition can make the engine closer to the stoichiometric condition. This may answer on why the experiment shows more efficiency on the rich configuration. Lastly, eco condition is when the lambda reaches above 1, which is actually lean condition, but the reaction of the car would be coming slower. So the conclusion of this experiment is that the rich configuration could be more efficient and span longer distance when using these experiments parameters. Lean configuration is less efficient, and this may also be due to the several variables that is mentioned in several previous slides. The effect of the lean configuration to the heat may affect its performance in this experiment run. Other than that, the expected error that may also affect the variable in this experiment found out during the analysis are also listed here. The first one is the arrangement of the experiment running that may affect the experiment data. The second is the condition of the motorcycle also need to be considered. Third is the fuel that is left in the tank that may also affect the experiment running. The fourth is the constant velocity that is cannot be maintained in the exact constant speed like cruise in the car. And the last is the temperature difference due to different time and weather condition. So maybe that's all about the thermodynamic experiment. I am Dzulkifly. See you in another project.